So moving on to lesson 2 in chapter 9, we're going to talk about ellipses. All right, and ellipse is essentially an oval shape. So let's talk about the parts of an ellipse real quick. All right, so in an ellipse, of course, the very middle is the center. All right, and this line that goes through the center along the long part of the ellipse is called the major axis. Okay, so that red line there is called the major axis, and it's again, it goes through the center, but it shows the distance from the longest distance from one point to any other point on the ellipse. So these 2 points here at the end of the major axis are the 2 points on the ellipse that are the farthest from each other. All right, and then you've got the minor axis, that's the other red line right here, okay, and it goes through the center, and it's the 2 points on the ellipse that are closest to each other, as far as points being across the ellipse from each other. So you got your co-vertices here and here, and you got vertices at the end of your major axis. All right. Now these points that lie on the major axis are called foci. Okay, foci. Each one is called a focus. Right, just like you have a focus for a parabola, you have 2 foci for an ellipse. Now, the thing about an ellipse with the foci is that if I draw a line from one foci to any point on the ellipse, and then draw a line from that point on the ellipse to the other foci, okay, those 2 distances of those lines are always going to add up to be the same for every point on the ellipse. Okay, so the point right here, the distance to this foci and the distance to the other foci across the ellipse will add up to be the same as the distance from the 2 foci to this point. All right, so that no matter where you're at on the ellipse, the distance to the 2 foci should add up to be the same thing. All right, so that's most of our stuff on here, and then of course you've got no, that's about it. Now this A, B, and C. All right, A is the distance from the center, all right, to the vertex, okay, to each vertex. So it's going to be the same. It's going to be the distance to this vertex and the distance to the other vertex. B represents the distance to each covertex, okay, so the distance from the center to the covertex and the center to the covertex. And then C represents the distance from the center to each foci, okay. And there's a cool formula that happens with these 3 values that we'll use a lot with ellipses here in a few minutes. And up here's this formula. It looks like Pythagorean theorem, only except for a squared plus b squared, it's a squared minus b squared. So whatever this distance on this ellipse is for A, you can plug A, B, and C into this formula, and it should always hold to be true. Okay, so this is some important stuff to remember about an ellipse. A lot of terminology here that we'll use throughout this lesson, and we're definitely going to use this formula a lot. All right, so let's go ahead and do some practice problems first. Let's look at finding the standard equation of an ellipse. Now let's look at the basic form of the equation of an ellipse. So it's kind of similar to a circle in that you got 8x minus h squared, all right, plus y minus k squared, just like a circle, all right. But you're going to divide these 2 fractions by a and b, and that's a squared and b squared actually, and that is the same a and b that we were talking about on the last slide, where a is the distance to each vertex and b is the distance to each covertex. Okay, and it's always going to equal 1. Okay, for an ellipse, we're always going to make it equal 1. So with circles, it equals r squared. With an ellipse, it's always going to equal 1. Now you could also have your equation like this, where you've got x minus h squared, but x is over b squared, and then your y minus k squared is over a squared. Okay, so the difference right here is which is essentially, is your ellipse a horizontal ellipse or a vertical ellipse? Okay, now remember, A is the value on the major axis, right? So A is always the biggest number. A is always going to be bigger than B because A is always on the major axis and B is on the minor axis. So whenever A is under X, that means that we have a horizontal ellipse because the longer value is with X. So it's going to go longer on the X-axis and it's going to end up giving us like a horizontal ellipse like that. But whenever A is under Y, or the bigger number is under Y, that's going to give you a vertical ellipse. The long side is going to be going vertically. Okay, pretty awful ellipse, but you get the idea. All right, so let's look at taking some information and writing the standard form of the equation of an ellipse. So this problem says find the standard form of the equation of the ellipse having a foci at 0, 1 and a foci at 4, 1. And we know that the major axis is of length 6. All right, so let's just think of a little sketch right here. So we've got foci at 0, 1 and at 4, 1. Alright, so if the foci are running horizontally, then we know we have a horizontal ellipse, something like this. Alright, so you can draw a little sketch to get an idea of what it looks like. And the major axis is of length 6. So from here all the way across through the foci must be 6 units long. Alright, so we know that that's 6. Okay. So what we need to find is the center. Okay, so that's what H and K are, right? HK represents the center. And then we need to know the values of A and B. So let's find the center. If we know the two foci, the center is going to be halfway in between those foci. So what we need to do is take these values and find the midpoint. To find a midpoint, you add up the values and divide by 2. So 4 plus 0 divided by 2. And then 1 plus 1 divided by 2. 4 plus 0 is 4, divided by 2 is 2, 1 plus 1 is 2, divided by 2 is 1. So I know my center is going to be at the point 2, 1. Okay, so that's H and K, right? So let's write that in blue. This is my H, and this is K. Okay, now let's figure out what A and B are. Well, we said that A, remember A is the distance from the center to a vertex. But we just said our minor axis in the problem we're told is 6 units long. So if it's 6 units from the vertex all the way to the other vertex, then halfway would get us to the center. And that would be our value for A. So take half of 6, and that's our value for A. So we can go ahead and start listing those. A is half of 6, which is 3. Remember, C is the distance from the foci to the vertex. So C is going to be the distance from 2, 1 to 4, 1, or from 2, 1 to 0, 1. So that's obviously 2 units. All right, now we're going to use our formula that's like Pythagorean theorem, only it's minus, to figure out what B is. So A squared is 3, so we got 3 squared minus B squared equals C squared, which is 2. So that's 9 minus B squared equals 4. So subtract your 9, negative B squared equals negative 5. And then divide by negative, so B squared equals 5. Okay, now I could take the square root, but remember my formula is B squared. So I don't need to find B just to plug it back in and square it. I know B squared already. B squared is 5. So I can just replace the B squared right here with 5. And of course I know A is 3, so I can plug in A, and I can plug in my H and K. So now let's write our function. We're going to have, and pay attention to where A is. A is going to go on the under the X, right? Because this is a horizontal ellipse. So I've got to make sure I put the biggest number, which of course is still, it's, see, yeah, A is going to be the biggest number. We're going to put it under X minus H squared. So let's write our function. I've got X minus H, which is 2, so I can actually erase that and put 2. X minus 2 squared over A squared. Well, A is 3, so 3 squared is 9, plus Y minus K, which is 2. Again, messing up. Y minus 1, not 2. Y minus 1 squared over B squared, which I said was 5, equals 1. Okay, so there's my answer. That's the standard form of the equation of this ellipse. Okay, so you guys try the one at the bottom. Make sure you pay attention to what information you're given and figure out A, B, C, and figure out H and K, and then you can write your equation. Okay, so we have foci at 0, 0 and 0, 8. So I just drew a little sketch here. Foci are at 0, 0, and 0, 8. And notice this time the foci are going vertically. So this is going to give us a vertical ellipse. All right. So it's important to recognize that. So when you put your A and B in, you put them under the right letter. Now our major axis is of length 36. So if it's 36 from the bottom to the top, then the distance from the center must be half of 36, which is 18. So the value for A is 18. A is the distance along the major axis from the center to the vertex. All right, then we've got our foci, right, at 0, 0, and 0, 8. So halfway between those, you can use the midpoint formula, or you can just, count. No, it's 8 from one foci to the other, so 4 has got to be halfway. So 0, 4 is the center. So it's important to identify your center because that's H and K. Now, once we know A, we can figure out what C is, because C is the distance from the center to the foci, so that's 4. And when you know A and C, you can plug them in to figure out what B is. So we do that right here and solve, get B squared equals 308. Now again, we don't need B really, we just need B squared. So once we know B squared, we can plug them into our formula. So I'm going to say X minus, and we'll put H, which is 0. Okay, so you really don't need a minus 0. When there is a 0 there, you can just put X squared. Alright, over. Now, remember this time, B is going to go under X, okay, because A is the long side, right? A is the distance from the center to the vertex. So A this time is on the y-axis. It's going vertically. So the big number this time is going to go with A. So I'm going to put B squared under X squared. B squared is 308, so I'll put 308 plus, and then in parentheses I'll do y minus the center, the y coordinate on the center, which is 4 squared, over A squared. So A squared is 18 squared, which is 324. And then that's going to equal 1. Alright, so that should be your equation for this one. Okay, so let's move on and look at how to sketch an ellipse that's given by the equation, right? So we get the equation, and we want to identify the center and vertices and graph this ellipse. So this is pretty simple. First thing you've got to do is just make sure that the equation equals 1. So in order to make this equal 1, we want to divide by 36. Okay, so let's take everything and divide it by 36. So we're going to divide this fraction by 36. We're going to divide the y squared by 36. And then when we divide 36 by 36, we get 1. Okay, let's reduce. So we get x squared over 4 over 36 reduces to 1 over 9. And then this one doesn't really need to be reduced. It's just over 36 equals 1. Okay, so what we need to do is identify what's our center, right, and what are A and B. Once you know your center and you know A and B, you can sketch the ellipse pretty easily. So our center right here, well, there's nothing being added or subtracted to X or Y, so the center is the coordinate 0, 0. A is the bigger number, right? So the bigger number is right here, but remember that's A squared. So take the square root of 36 to find A. A is 6. And then B is the square root of the smaller number. Square root of 9 is 3. So again, A and B are the distance from the center to your vertices for A and co-vertices for B. So let's draw the center at 0, 0. Alright, then we're going to go 6 from the center, but remember you got to do it along the y-axis, so vertically, because we got 6 from the y fraction. So we're going to go 6 from the center vertically. So 1, 2, 3, 4, 5, 6. There's one vertex, and then 6 the other direction. 1, 2, 3, 4, 5, 6. So there are our vertices, and then we're going to go 3 along the x-axis. 1, 2, 3, and 1, 2, 3. Okay, so that gives us our points to draw an ellipse, and at that point you just do your best to draw an ellipse. I'm going to use this cool tool because I can, and draw as close to one as I can to get it to go through all the points. That looks pretty good. Alright, so there is a sketch of the ellipse, and if you want to identify the center and vertices, we can just label those. Center is 0, 0, and then your vertices are at 0, 6, and 0, -6. Okay, so you guys try this one down here. and let me know if you need any help, and I'll go over it. Okay, so right here you can see the ellipse, that's your answer, and I did that by dividing by 36 to make everything equal 1. Then I can identify A is the square root of 36, which is 6, B is the square root of 4, which is 2, and your center is at 0, 0. So then you graph your center, and we count 6 on the x-axis, right? Because we got the biggest number from underneath x squared. So we go 6 on the x-axis, and 2, on the y-axis, and then we can draw our ellipse. And of course your center is at 0, 0, and your vertices are at 6, 0, and negative 6, 0. So that's where you would say your vertices are at. Okay, let's look at another problem. So this time we're given the ellipse in general form. Okay, so we did this with circles, where we're given the equation in general form, and we need to change it to our standard form in order to be able to graph it. So what we're going to have to do is complete the square. So I'm going to group the x's together first. So we got x squared plus 6x. Okay, and I'm going to leave space right here to complete the square. Now I'm going to put my y's out here. Plus 4y squared minus 8y. All right, and then move the constant, leave some space, put your equals, and then put the constant number on the other side. So I'm going to subtract 9 to the other side, all right, to make sure it equals some other value, right? Okay, so now at this point, we want to complete the square. So we're going to complete the square for this and the x squareds, and also for the y squareds. So I'll go ahead and do it for the x squareds, but we'll have to change the y squareds up a little bit before we can do it. So first, to complete the square, remember you take half of the number in front of x and square it. So half of 6 squared, right? That's 3 squared, which is 9. So I'm going to add 9. All right, and then we do the same thing for the y squareds, but with the y squareds, you've got a common factor that we need to take out. So we're going to take out a 4 first. All right, so let me rewrite the x squared part, x squared plus 6x plus 9. Now I'm going to take out a 4, and then in parentheses, I'm going to put what's left, y squared minus 2y, right? Because I took a 4 out of both of them. Okay, now the place that I complete my squared at is right here, so I'm going to take half of 2, well, really half of negative 2, and square that. So that's going to be negative 1 squared, which is 1. So I'm going to add in a 1 right here. Now, again, it's important to be aware that since you took out a GCF of 4, this 4, remember, is distributing to everything in this parentheses. So that's really 4 times 1. So really what I did was add 4 in to the problem, right? If I distributed, I would have 4y squared, which is right here. I would have minus 8y, which is right here. And then I would have plus 4. So I really changed it by adding 4. So over here on the right side, well, you got the minus 9. Okay, we're going to leave the equals minus 9. But we need to add on a plus 9 because of the 9 that we added for the x's. And then we need to also add on a 4 because of the 4 that we added on for the y's. Alright, so we add all that together. Now we can factor this into a binomial. So we know that by factoring this, we're going to get x plus 3 and x plus 3, which is x plus 3 squared. Okay, which is what we want. We want a binomial squared. If we don't get a binomial squared, we know we messed something up. And then right here, same thing. We factor this, we're going to get minus 1 and minus 1. So it'll be y minus 1 squared equals, and then negative 9 plus 9 is 0, plus 4 more is 4. Okay, so the last thing right here we need to do is just divide everything by 4 to make it equal 1, right? Because we want the standard form of an ellipse, it's got to equal 1. So we're going to divide all of our fractions by 4. So we get x plus 3 squared over 4 plus y minus 1 squared over 1, right? And you don't have to put over 1. You can just leave it like that without the over 1, but it's going to help me to see it over 1 to identify A and B. Alright, so now we want to graph the ellipse. So now it's standard form, it's easy to graph it. We just need to identify our center. So our center is at -3, 1. And then our value for A is the square root of 4, which is 2. And our value for B is the square root of 1, which is 1. So once you know A, B, and your center, you can graph it. So -3, 1. This is our center. A is 2, so that's the distance from the center to the vertices. Remember, this time A came from X. You always got to pay attention. Did A come from X or Y? So since it's A is under X, that means I'm going to go 2 on the X axis, so 2 horizontally. And then I'm going to go 1 vertically. So a pretty small ellipse right here on this one. All right, so there's our ellipse, and that's how you graph an ellipse whenever you're given it in general form. First, you got to complete the square to change it to standard form. All right, then you can identify your center, your A and B, and graph it. I give this one a try down here. I know this isn't an easy process, but give it a try, and then we'll go over it. All right, so I went ahead and started part of this, and I'll go over the rest of it with you. So first, we want to subtract the 37 to the other side, and group the x's together and group the y's together. So from there on, we're going to complete the square for the x's. Notice that 9 will go into 9 and 54. So we take out a 9, that leaves x squared and minus 6x. Okay, then we got to leave a space to complete the square. So we take half of -6 and then square it. That's -3 squared, which is 9. So we're going to add in 9. Now again, be aware that when you take out a GCF like we did right here, you really aren't adding this number. You're adding that GCF times that number. So we really are adding 9 times 9, which is 81. So on the right side, I need to add 81. Okay, then do the same thing for the y's. I'm going to take out a 4, because 4 will go into 4 and 40. That leaves y squared plus 10, and that should be a y right there. So y squared plus 10y. And so we take half of 10 and divide it by 2, or sorry, take half of 10 and square it. That's 5 squared, and that's going to equal 25. So we add in 25. But remember, that's the GCF of 4. So 4 times 25 is 100. We're really adding 100. So we add 100 to the other side. So then from that point, we can start to factor each trinomial. So when we factor this, we get x minus 3 and x minus 3, which is x minus 3 squared. And then on the other one, we're going to do y plus 5 and y plus 5, which gives us y plus 5 squared. Then on the right, when we add these three numbers, we get 144. Okay, now we're going to, of course, divide everything by 144. Divide each fraction by 144. And make sure that we reduce the fractions. So whenever we do 9 over 144, you're going to get 1 over 16. So we've got x minus 3 squared over 16 plus, and then we do 4 divided by 144, you get 1 over 36. So we've got y plus 5 squared over 36. Alright, then that's going to equal 1. So we can identify our center is at 3, -5. And then our A value is the square root of 36, which is 6, and B is the square root of 16, which is 4. So we're going to graph our center at 3, -5 down here. And this graph might not have enough room, but that's all right. A is 6, so we're going to go 6 on the y-axis because we got the 6 from y. So we got to go 6 up, 2, 3, 4, 5, 6, and 6 down, 1, 2, 3, 4, 5, 6. Got to kind of use your imagination on this one a little bit. And then we go 4 to the right and left. 1, 2, 3, 4. And 1, 2, 3, 4. Okay, so a pretty big ellipse on this U-try right here. Don't you wish you had this cool little tool to use to draw yours? Alright, there you go. So there's your ellipse for this problem. Let me know if you need any help on these. And let's look at the last example. So analyzing an ellipse. Alright, so this is essentially doing the same thing we just did, using completing the square to write your general form and standard form, and then just identifying from standard form what are your center, what are your vertices, what are your foci, all those different kinds of points. Alright, so let's look at doing one of those, and then we'll do this U-try down here. But it's not much of a different process. So we're going to go ahead and let's rewrite the function 4x squared. And let's put the x's together, minus 8x plus y squared. And then we've got plus 4y equals, and let's go ahead and move the 8 over. Okay, so let's go ahead and take the GCF for the x's. That's a 4. So in parentheses, we're going to leave x squared minus 2x, and then leave a space to complete the square, plus, now the y squared this time doesn't have a GCF, so we don't have to worry about it this time. So y squared plus 4y, and then we'll leave a space, equals 8. Okay, so let's figure out what goes in our spaces to complete the square. So if we take half of 2, that's 1, and 1 squared is 1. So I'm going to add in 1 right here. Well, what did that really add to this whole side of the equation? Well, we've got a GCF of 4, so 4 times 1 is 4. We really added 4. So let's add 4 to the right. Now over here we take half of 4, which is 2, and square it, which is 4 again. So we're going to add 4. And this time we really are adding 4 because there wasn't a GCF that was factored out right here. So there's nothing to distribute back. So we really did add 4, so we need to add 4 to this side. Alright, so there we go. Now let's go ahead and factor our trinomials. When we factor this, we get x minus 1 and x minus 1, so it's x minus 1 squared. If you notice, this number is always half of this one. Okay, so it's a quick way to think about it instead of trying to factor. Just take half of that number. You can see this one, it was 6, so it was 3. Right here it was negative 2, so it was negative 1. So it's always going to be half of whatever the trinomial number is. So it's just a quicker way to do it. And then right here we've got half of 4 is 2, so it'll be y plus 2 squared equals 8 plus 4 is 16. Now to get it in standard form, we need to divide everything by 16. So that gives us x minus 1 squared. 4 over 16 is 1 over 4. And then we've got y plus 2 squared over 16 equals 1. Okay, so again we want to find the center, vertices, and foci. Well, we can find the center now. We can identify it. Your center is 1, negative 2. All right, you just do the opposite of these to find h and k. That's a terrible sign right there. That's a plus, but it looks really bad. So there's our center. Our vertices, okay, remember your vertices are the distance from the center to A. Or sorry, from your vertices are A, right, from the center. So we need to figure out what's the value of A, and then figure out if we go that distance from the center in the proper direction, what points are we going to get? Alright, so let's go back here. So if my center's at 1, negative 2, A is 4, right? So A is 4, and B is 2. So we got to use A to figure out where the vertices are at. So we're going to go 4 from the center, and which direction? We're going to go vertically because A came from the y fraction. So if I go 4 above this and 4 below that, my vertices are going to be at 1, positive 2. And if I go 4 below that, I'll get to 1, negative 6. Right? Because the y value is going to go up 4 to 2 and down 4 to negative 6. So those are my new vertices. Now we want to figure out the foci. Remember, the foci we get from C. Well, we don't know C. All we know are A and B. So you've got to use your formula, A squared minus B squared equals C squared to find C. So that's 4 squared minus 2 squared equals C squared. That's 16 minus 4, which is 12. Okay, so C is going to be the square root of 12, which simplifies to 2 square root of 3. Alright, so we're going to add this to the y coordinates, just like we added 4 to the y coordinates, because remember your foci are also on the major axis with the vertices, right? So we're going to add 2 square root of 3 to this y value. So my foci are at 1 and 2 square root of 3 minus 2 if we added it on. And then our other foci is going to be at 1 and then negative 2 square root of 3 minus 2 if we subtracted it to go down, right? So there's our two foci, our two vertices, and our center. Okay, once you find that foci, add and subtract it to that y-coordinate if it's on the y-axis. If it was on, happened to be the bigger number was under x, then we would add and subtract it to the x-coordinate. Okay, so that's what I did right there. Just took a and added it to -2 to get 2, and subtracted from -2 to get -6. Then I do the same thing with C to find my foci. And yes, this is the way you should leave it in radical form. All right, give it the last one a try, and we'll go over it. So you guys are going to hate me because this one involved a lot of fractions, but it's important that you be able to do these with fractions as well as whole numbers. So not always going to be as clean and nice as we'd like. All right, so first we're going to group the x terms together and the y terms and move your constant to the other side. So that's why we got the -2 over here. Now complete the square, so we got to take out a 6 from both of these. When we take out a 6, that leaves x squared plus 3x. So then to complete the square for this one, we take half of 3 and square it. Half of 3 is 3 halves squared, makes 9/4 because you square the numerator and square the denominator. 3 squared is 9, 2 squared is 4, so we put 9/4 in. Now again, be aware that that's 9/4, but it's multiplying by the 6. So 6 times 9/4 gives us 54/4, which reduces to 27/2. So I add 27/2 to the other side. Then complete the square with the y's. You got to factor out a 2 as a GCF. That leaves 5. So you take half of 5 and square it. That again gives you 25/4 because you square the 5 and square the 2. So we add in 25/4. But really that's 2 times 25/4, which is 50/4, which reduces to 25/2. Alright, so then we're going to factor. So when we factor this, you take half of 3, right? Remember I told you take half of the number that's right here. So I take half of 3, 3 halves, and square it. And then over here, take half of the -5, so it's y minus 5 halves squared. And then equals, when we add all this together, these two fractions and the -2, we get 24. Now the last thing we need to do is divide by 24 to make it equal 1. So when I divide by 24 over here, 6/24 reduces to 1/4, and 2/24 reduces to 1/12. Then we got our equals 1. Okay, so now we've got it written in standard form. We can identify our center. Our center is -3 halves, +5 halves. Okay, so that's what we write here. And then our vertices are going to be taken by, or going to be found by taking A and adding it on to either the x coordinates or y coordinates, depending on where it came from. So A came from the y value. So again, just like the one I did, you need to add the A value onto the y coordinate from your center. So our vertices are going to be -3 halves, and then 5 halves plus 2 square root of 3, and -3 halves, 5 halves minus 2 square root of 3. So we just take that A value and add it and subtract it to the y coordinate for the center. And you're like, how did I get 2 square root of 3? Well, A squared is 12, right? A squared is 12, so you take the square root of 12 to find A. Square root of 12 simplifies to 2 square root of 3 because you can factor out a 2 because it's really 2 times 2 times 3. Again, assuming you guys can simplify square roots. So add and subtract that on. Then you got to find your foci. By doing that, to do that, you got to find C. So we know A and B. So we plug them into our formula. A squared minus B squared equals C squared. So we get 8 equals C squared. Take the square root to get C by itself. Square root of 8 simplifies to 2 square root of 2. So now to find our foci, you're going to add 2 square root of 2 onto the y values. So it's just like we did with the vertices, -3 halves and then 5 halves, but we add on 2 square root of 2 instead of 2 square root of 3 and subtract 2 square root of 2. So there's our two foci, and that's our answers for the center, vertices, and foci. Let me know if you guys need any help on this stuff, and you can do the practice problems that are over here on the first slide to give them a try. Make sure you're ready for them whenever we take a test.